The ocean. One of the most beautiful and mysterious parts of our planet. It is home to a vast array of life, from the tiniest plankton to the largest whales. But this rich ecosystem is under constant threat from human activity. One of the most harmful threats, fishnet. Though unassuming in appearance, millions of tons of fishing gear, especially fish nets, are lost or abandoned in the ocean every year. These nets, often referred to as ghost nets, continue to drift through the water, trapping and killing countless marine creatures. These ghost nets ensnare and kill marine wildlife indiscriminately. From small fish to turtles and even dolphins, all types of animals fall victim to these nets. Many become entangled, unable to swim or breathe, leading to exhaustion, starvation, or becoming easy prey for the surrounding wildlife. Fish nets also pose a significant threat to marine habitats such as coral reefs. When nets get tangled in the reefs, they break and damage the coral, which can take decades to recover, if it ever does. Made from durable synthetic materials like nylon, these fish nets can persist in the ocean for hundreds upon hundreds of years, causing continuous and perpetual harm. Over time, they break down into microplastics, which are ingested by fish and other marine creatures, eventually creating a ripple effect of harm up the food chain, which ultimately affects us, humans. Fortunately, efforts are being made to combat this pressing issue. Organizations are working to remove ghost nets manually and push for more sustainable fishing practices. While progress has been made, these methods have been slow and inefficient, leaving room for improvement. That is why we developed an automated solution to tackle the problem. By creating a robot designed to automatically cut, untangle, and retrieve these nets, we can actively combat the threat ghost nets have posed to our oceans for decades. Now, how does a robot work? First off, the robot closes into the tangled net. With the help of artificial intelligence and the usage of remote control, the robot selects the optimal location of the net for the buoy. As the robot attaches the net, the buoy attempts to float up, but cannot due to parts of the nets being snug. Using its two claws, the robot then makes necessary adjustments to the net by either cutting and or grabbing parts of the net as needed. After the net is freed, the buoy along with the net floats up to the surface to be collected by crew waiting. For its mobility, it uses propellers and carefully crafted fins in order to help with its mobility. Lastly, we decided to go with the design of bright yellow with flashing LED red lights. Why? This is to ensure that other wildlife around the area are repelled and see our device as a possible threat or a warning signal. Our robot is aligned with SDG goal number 14, life below water, as it can help save and protect our marine wildlife, and SDG goal number 6, clean water and sanitation, as it helped combat against microplastics. This has been Project NetBreak, freeing the futures for fish for tomorrow.